This free energy is something that is both present in the products and reactants, and because of that, it is often more insightful to consider the change in free energy between the products and the reactants. This difference is denoted by the delta symbol that accompanies the free energy, enthalpy, and entropy of the system. Now, in terms of the equations, the value that is most important for us is the change in free energy, delta G, which will indicate the spontaneity of the reaction. If delta G for a given reaction is negative, then the reaction will be spontaneous and is said to be exergonic. On the other hand, a positive delta G implies that the reaction is endergonic, non-spontaneous, and requires the input of energy to occur. Besides the sign of delta G, if its value approaches zero, then the reaction is said to be at equilibrium, which simply means that it can go either way in the forward or reverse direction. Typically, in metabolic reactions, that means that high amounts of reactants will cause the reaction to go forward in order to equilibrate with products, and similarly, high amounts of products will equilibrate in the reverse direction with the reactants. Lastly on this, reactions with delta Gs that are very negative are said to be irreversible because the reactants will always make the products regardless of their initial concentrations. So, as you can see here, the direction of the reaction, and by association the free energy, can vary on some conditions such as the concentration of reactants and products. Given that, there is also a standardized version of the Gibbs free energy that is denoted delta G naught. This version of free energy follows the same rules for the signs of delta G, and it allows to give insight on the nature of the reaction. However, the true indication of spontaneity that happens in vivo comes from this delta G because it uses the physiological conditions of the reaction. Now, to exemplify these concepts of thermodynamics, I want to consider the values of delta G naught and delta G for the process of glycolysis. Although we have yet to cover glycolysis, the idea here is really to see how metabolic pathways are set up and talk about some of their governing principles, as a lot of these thermodynamic features will apply in other contexts. So, if we consider our table, the first column shows all the enzymes that make up the pathway. If we take a look at a few of the reactions of this pathway, the enzymes are labeled in light blue, so GAP dehydrogenase or GAPDH, phosphoglycerate kinase or PGK, and enolase.